My confession is that it's not going to be very scientific, and I feel a bit intimidated by very high-powered scientists in front of me, so please don't ask me really difficult scientific questions. My company is a small company based here in Cambridge. It's been 4 employees up until recently. We're 3 at the moment. And probably about 50% of our work is in the polar regions, principally the Antarctic. A lot of that work is actually with the US Antarctic program, so what I'm aiming to do in this kind of overview of our work is just highlight some of the projects that we've been working on with the US program and how it relates to environmental management in the Antarctic. We do some work in the Arctic, but being a small company, we kind of don't have enough time to spend a lot of time on that. So much of it is Antarctic focus. Right, so broadly speaking, the sorts of things that we're engaged with is protected area management. And there's a system for protected area development and management in the Antarctic. I won't go into the details of that, but there's sort of a whole lot of procedures that you have to go through to develop protected area management plans. One distinction I would make is there's 2 broad types of protected area. There's what we call Antarctic Specially Protected Areas, which is the strictest form of protection, and Antarctic Specially Managed Areas, which is really just to give a better framework of management in the areas where there's a lot of activity going on. We use remote sensing in operations planning. So, for example, planning field work, and we want to see what's going on before we go out into the field. Visualization and education purposes, and also for environmental monitoring. I'm sure there's many more applications of remote sensing for environmental management, but these are the ones that I've kind of picked out as the main areas that we're working on. So, for the specially managed areas, we've got 2 sites that we're working on at the moment. One on the Antarctic Peninsula. There used to be maps of Antarctica and the Arctic here, but no longer, so everybody knows where that is anyway. So there's the Antarctic Peninsula, as a specially managed area number 7, the Palmer Basin, and the ASMA number 2 in the McMurdo Dry Valleys and the Ross Sea. ERA works with the US program on the development of these managed area plans, and a really important part of that has been developing good maps to support those plans. So really, from our perspective, one of the principal uses we make of remote sensing is for mapping as a base map. And as you appreciate, in the Antarctic, often there's very poor data available, and remote sensing is an essential tool to bring the data together. So what do we need to do when we define a protected area management plan? First of all, what's driving it really is the important values that are at the site. So sometimes we might use the remote sensing to help define what those values are, how extensive they are. An example would be a colony, a wildlife colony. It might be impractical or too difficult to map it from the ground, so we use aerial or satellite imagery for that purpose. And then when it comes to writing the plan, all of the key physical features that we need to describe that goes into the plan, generally speaking, remote sensing can be applied in different ways to make assessments of these things. The things highlighted in orange are sort of where remote sensing has a particular role to play. I mean, you might be able to use remote sensing for microbiology, but we're not doing it. So there's broadly 3 main types of maps that we develop for these plans. The regional view, which sometimes is not derived from remote sensing, but from other map sources. But very frequently, there's no site. There's no site map available at scales of less than, say, 1 to 250,000. For environmental management purposes, generally you need a map of a scale of maybe 1 to 10,000 or 1 to 5,000. So you need quite detailed mapping, and the only way to get it is to construct it from scratch, pretty much. And the third type of map is what I call thematic. So that would be vegetation maps, or it could be wildlife distributions and things like that. The landscape's totally changed in the last few years. When I started working in the Antarctic, which is going back 20 years, there was virtually no satellite imagery for the Antarctic. There was some Landsat scenes, there was a few declassified military scenes, but generally they were pretty poor and not really very useful, especially for environmental management. So back then we used to rely very much on aerial photography, but as you probably know, it's quite difficult to mount aerial photography expeditions. We did do that in the McMurdo region, so figure out my point there. McMurdo's here, and the dry valleys are just in this area. When we were developing a management plan for that region, we did actually organise a aerial photography mission with New Zealand government support. US was involved, Italy was involved, and we put this mission together. It took about 3 months to actually run it, and we acquired lots of great photos, and that was that. That was all the imagery we had for the next 10 years, sort of thing. In the last couple of years, we've seen new satellites coming on board, particularly QuickBird and now WorldView. And through our work with the US program, we've been given access to all of the imagery that's been acquired using those sensors. So literally thousands of images are available. And because we're working with the US program, they're available free, which is rather nice, makes a big difference. And so if it wasn't free, it'd be millions and millions of dollars worth of imagery. So practically speaking, we couldn't afford to buy that stuff. So through an arrangement with the US government and the NGA, or National Geospatial Agency, it's called, they've made this imagery available in the Antarctic for research purposes. And it's making a huge difference to what we can do. This map is just a kind of footprint of the imagery that was acquired as of March. And just last week I was in Minneapolis with the guys that are assembling this data. And I haven't got the most recent footprint, but it's pretty much all black now. So just in 6 months, we've got loads more imagery. So increasingly we're using that image base as our sort of tool of choice, if you like, for mapping. And this is a QuickBird image in the Dry Valleys region. Multispectral, 2.5 metre, and panchromatic is about 0.5 metre. So it's quite good quality. For environmental management purposes, often you want even better than that. You'd like to go down to, say, 0.25 metre. Can't really do that at the moment, but it's pretty good. So what are we doing in the Dry Valleys? There's some various protected areas and what they call special features dotted throughout the region. And when we started a couple of years ago, there were no maps for those sites. And in fact, they're very poorly described. So we, for the last couple of years, we've been assembling data on those using a combination of remote sensing and field surveys. And we're putting all of these maps together for a revision of the management plan for the area, which will go to the treaty possibly next year. So this is one of the sites that we're working at. It's called Lake Bonnie in the Taylor Valley of the Dry Valley. And this image map is created from the 1993 photography. Reason we used that as our image base initially is because its pixel resolution is down to 40 centimeters with colour.